Hello, we're the Brooklyn Project, and I'm Timothy,
I'm Will.
And I'm Michael.
and we're here to talk about our design project, which is a nuclear probe. And I'm going to start off with the engineering design cycle, which is the first thing we do is ask what our probe is going to do, which is measuring a certain type of radiation, which is called Cherenkov radiation, which is in the form of a blue light. So we need to measure it using a photosensor, which is either a photodiode or a photoresistor. And after we ask what we do, we ask what are our constraints, which is the $40 budget. And we need to dip our sensor into the reactor, which is submerged in a pool water. And so in order to protect our photosensor and the wire, we need a PVC pipe. And so we imagine how it would be designed, which is the next step. So we put our sensors and the wire into the PVC pipe, and then we hooked it up to a multimeter and we put it in the water. And the PVC pipe has to have a window, which we think we used a plexiglass to cover one side and use it as a window, and then use PVC cement to cover up the sides so water does not leak into it. And then we planned, the next step is we plan when to buy our stuff and the photosensors and wires and PVC pipes. And then we also plan, we sketch the design of the probe. After that, we create the probe and then we test it. We test it by using flashlights, and if it works, the multimeter will give off readings according to the intensity of the light. And then we do the measurements in the Burlington labs, and if we fail or if our photosensors did not give any readings, we ask what failed and we improve the design.
Alright, and now on to some of the main challenges that we faced. We basically had two main challenges, and the first was communication with our project manager in the university. And so basically at the time of the first milestone, we weren't sure about some things on how to start and complete a construction. So more specifically, we weren't sure if we had the correct photodiode because it was so small that we weren't even sure how to solder it onto the wires. And then we weren't sure exactly how to attach the wires to the voltmeter once we got that, and we weren't sure how or where to test the probe once we had finished completing it. And then later on, we weren't sure. We weren't sure exactly where to get all the materials that we needed to complete construction. And moving on to the second main challenge, we tested the probe the first time and we realized that we weren't getting any readings, and so we weren't sure if it was if the device wasn't working, or we really weren't sure what happened. So we were able to communicate with our manager, and she was able to give us a new diode or resistor, and we were lucky enough to find another test date, and it worked the second time. So now, moving on to the performance on FEDD, we actually placed second among all the other nuclear probes in the first time slot. And when we were at the McKimmon Center, we received a mystery power level of 650 kilowatts, and we originally calculated it at 655, so our percentage error was only 0.7%, which seemed to be much better than some of the other groups.
Then we're going to move on to things we would have done differently, and you're going to notice that a lot of these things are similar to the challenges that we had. So first things we would try to done differently is we would try to connect it with our project guru a little earlier. At the beginning, it probably wasn't necessarily all on us, miscommunication. Our project guru was actually out of town, but that was something that we would try to do early. Everything basically we try to do earlier than we did. Especially testing our components, because we actually determined that the photodiode that we had didn't actually work until about a week before FED, and so we were lucky enough that we got another photo resistor, and we're able to test it the Friday before FED day. So we got very lucky in that regard. So the earlier we would have done it, the more adaptable we would have been, and a little less stressful time crunch at the end. And then going off that, our advice to incoming freshmen would definitely be to start early in every aspect of the design, whether it's connecting with your guru and other members of the engineering department, or just planning out team meetings early. Definitely would have done that. We felt like we were strong on working with ourselves early and planning out what we needed to do, and that helped us out in the long run despite having our communication issues and our equipment failures. And then so I would say also test your individual components and really see if it's logical what's going on, because as soon as our original photodiode came in and we looked at how small it was and figured out what we had to do, it seemed a little ridiculous. And so if you just think through it logically and early, so you don't have any kind of time crunch and stress yourself out. I would also say planning is a huge part of this as well, because you don't want to sit down right before a milestone is due or try to do this project all at once, because then it's going to get really stressful and it's not going to be as efficient as you want it to be. And so I would say more advice is to have weekly meetings set up early and try to get to those meetings and talk through upcoming work. So whether your meeting is only 10 minutes long because it's early on in the semester, sit down with your group, talk about what's going on, and so everyone has a firm understanding of the progression of your project. And then so our sources we had were Elmer Lewis's Fundamentals of Nuclear Reactor Physics, James Mahaffey's Nuclear Power, Nuclear Fission Reactors, and a Serenkov radiation article from Pergamon Press, which is a scientific journal. And so that was our project. We were very pleased with the outcome, despite some rough bumps along the way, but we felt it was a very good learning curve and learning topic for us. So we're the Brooklyn Project, and we did the Nuclear Pro.